Hey, what's up guys? So today we are going to learn visualization in MATLAB, and we are given three functions here in this problem and a domain for x and y. We'll start by drawing the surface. First let me open the MATLAB here and just arranging it so that you can see both the MATLAB and the notepad for the question and the command window. Yeah, we will start by drawing the surface today, and just make sure that you have the symbolic math toolbox. I have it installed, so if you don't, make sure it's added in your add-ons. Let's draw the surface. So we are given three functions a, b and c, and also we have the x and y variables that are belonging to the domain from -10 to 10. So use syms xy. We have assigned the variables x and y, and we will just copy and paste these functions because these will remain the same, and it's super easy to draw the surface in MATLAB. Just use fsurf. We cannot use surf here because the equations we are given are in terms of the explicit functions of each other, so that's why we'll use the fsurf. ABC, yes, and we will stick to the domain that we are provided for this question. This is important. Yes, and now maybe we can run the section. Yeah, so that's how you can draw the surface. It's super easy, there's nothing difficult. Yes, and maybe we can just change the color of the surface if we want. Oops. Okay, yeah, I have given it a green color. Let's see if it changes. Yeah, so we have the surface in green color now. We can also change it to another color like cyan. Now I'm changing it to cyan color, or maybe to yellow as earlier I was doing. Yes, so the color changes. You can choose any color that you want, but here I'm not going with any color. So drawing the surface in MATLAB is very easy. Now we will draw the point on the surface, and also with corresponding isocurves, and then we'll draw the normal vector of surface at P. When we are drawing a point on the surface, we need to make sure we put hold on, because we are making the point onto the surface, so it's important. So keep that in mind. So we will make the point on the surface where x equals 2 and y equals 3. For x and y, we will use x0 and y0 because we have already assigned the syms variables x and y for the original function. Making the point is very easy. Just need to substitute the original functions with the given coordinates. Replace axy with the ax0 y0, bx0 y0, cx0 y0. It's a good practice to put terminator at the end of each statement. We'll plot the point. We will use the plot 3 functions because we have the point at 3 axes. plot 3, P of 1, P of 2, P of 3, and we will give it a red color because we are asked that in the question to make a red dot. So that's why we have used the red color and the marker size of 25. You can use any marker size. Just for a better visibility, I have used slightly larger. Yeah, here we can see we have the point on the surface. Now we will also make the corresponding isocurves. So we will make the individual isocurves at both of the points x and y. So first we will make the isocurve 1 when x is stationary and y0 runs through its range. For this we will use a variable u that we haven't used before. We are basically substituting the y coordinate into the original functions. And now we will plot the curve using fplot3 because we have been using 3 functions before: fplot3, ua, ub, and uc. And we will also stick to the domain that we are provided in the question from -10 to 10. Copy and paste here, and we will give it some color, just blue here, and some line width, maybe of 2. We can use 2. Now as we can see, we have the curve in the blue color. Yeah, we have the curve here. It's also folding back to the other side. Yeah, now we will make the curve for the y as we have made for the x here. We will just copy and paste this part of the code and substitute every u with the v and every x with the x0 and y0 with y. That's it. Now we have both the curves here. As we can see, we also have the blue curve from x and the green curve from y. Now let's maybe use a dash line and an arrowhead so that we can see the curves more clearly. Let's run the section now. I hope we can see it more clearly now. Yes, as we can see it more clearly now. Yes, we have both of the curves also folding back. We have also completed the second part of the question, and now we will draw the normal vector of the surface at P. We need tangent vectors for the normal vector at both of the coordinates x and y, so that we can make the normal vector at the intersection of both of these coordinates. For this we will use the differentials. We will take the differentials of the above functions for the isocurves. And the reason we are taking differentials is that we need the intersection of both of these tangent vectors so that we can get the point where we have to draw the normal vector. Now we'll substitute back the differentials. Substitute x0 here, also for UBD, and same for the third one. Now we will use the quiver 3. this is used to make the tangent vectors, as we have 3 axes here. We substitute the uz into the quiver3 function. Yes, and that's how we can get the tangent vector at x coordinate. We will also have to do the same for the y coordinate, just making a copy of this part of code. So that was the tangent vector for x. So now we are making the tangent vector at y, just copying it so that you can follow through the code easily, replacing every u with the v and every x with the y. That's all. It's not very difficult, you just need to practice a little bit and you will get used to these functions. Yes, so now we have almost completed the steps to make the normal vector. Now we can calculate the normal vector. So we'll use the normVec variable. We can give it any name. We will use the cross, of course, because we need to calculate the intersection uz and vz. And yes, now we'll substitute back this normal vector into the previous tangent vector that we have created with quiver3. Instead, for this time, we will use normVec 1, 2, 3 instead of vz. So that's how you can see it's quite easy. And normVec 3, and now we should be getting the normal vector we need. And yes, just giving it a line width of maybe 2, giving it a line width of 2. Yes, now let's see if this actually runs through. And there it is. As we can see, the normal vector in the yellow color. I don't like this color much because it's not quite differentiable from the others. So we'll give it a distinct color, like something like black. Remember guys, K is used for the black color. You can also check the MATLAB beginners documentation and you can read the color coding from there. And we just need to run the section again, and yes, we have the vector in the black color now. That's all guys. We have completed the problem that we were given, and hope to see you in the next one. And thanks for watching this video.